All right, it's everybody's favorite day using problem-solving strategies and models. Um, my goal is to make this to where it's not that big a deal for you anymore. So we're going to take some words and turn them into problems. Let's go. All right, the first strategy, use a formula. This one says the Acela train travels between Boston and Washington, a distance of 457 miles. The trip takes 6.5 hours. What is the average speed? Well, distance, as you know, you've used this formula before. Distance is rate times time. And it tells us the distance is 457 miles. We don't know the rate, that's what we're looking for, but we do know the time is 6.5 hours. So we're just going to solve the equation simply by dividing both sides by 6.5. If I do that, 457 divided by 6.5, 6.5, you get about 70.3 miles per hour. Kind of a weird number, but it was a weird miles too, 457 miles, so that's okay. And so sometimes you know a formula, use the formula. Strategy 2, look for a pattern. Looking at the pattern here, let's read it first. A parameter is I guess that's how you say that, is a parachute propelled by a fan-like motor. The table shows the height of a paramotorist T minutes after beginning a descent. Find the height of the paramotorist after 7 minutes. So what's happening here, look for a pattern in the table. Every minute, it looks like it's going down 250, 250, it is. It's going down 250 feet. I think it's feet, didn't really say, per minute. So one thing you could do, I guess, is you could just say, okay, let's keep subtracting 250 until we get to 7. Another thing you could do is say, okay, the height starts at 2,000 and it is dropping 250 every minute. Actually it says T minutes. I probably should have used T for minutes, but it's okay. And so, if I plug in 0 in here, like if I take that 0 that's right here and plug it into my equation, 250 times 0 would be 0, and it would leave 2,000, which is right. If I took the 1 and plugged it in, it'd be 2,000 minus 250, so that's perfect. So all I can do to solve this is plug 7 in for the M, or if you use T, that would be fine too. And then punch that in a calculator, and I'm doing that right now as we speak. Let's see, 2,000. Let me do this first. 250 times 7. I'm having to use my phone calculator. Is 1750, so I'm doing 2,000 minus 1750, which is 250. So the final height after 7 minutes is 250. I'm going to put feet. I'm not sure it said in the problem, but 250 feet. It does say it right there in the table. It has feet. Let's try another one. Draw a diagram. Let's read this problem. You are hanging 4 championship banners on a wall in your school's gym. The banners are 8 feet wide. The wall is 62 feet long. There should be an equal amount of space between the ends of the wall and the banners. It should look good, is what it's trying to say, and between each pair of banners. How far apart should the banners be placed? I should say placed. A little typo there. I made a mistake. That's okay. It's okay to mess up. Okay, so I about took a picture of this picture so it would look better, but then I thought, no, you need to see how terrible of an artist I am. So let's see. There are 4 championship banners, so it's going to be one here, one here, one here, and one there. Okay, and it says this. It says they're 8 feet wide, so each one of those is 8. And what we're trying to figure out is how big the empty space needs to be to know where to put them. So let's say there's X there, X there, X there, X there, X there. So there's my picture. So what I know is if I add up all those distances, those lengths, I should get 62 feet long because that's how big the wall is. So let's count it up here. There's 1, 2, 3, 4, 5 X's. I could do this. I could add X 5 times, which is okay. And I could add 8 4 times like this. And I should get 62. But I think if you add 5 X's, you're going to get 5X. If you add 4 8s, you should know that that's 32. So just solve your equation. Move the 32 over, and you get 60. Divide both sides by 5, and you should know this one. 60 divided by 5 is 12, so that should be 12 feet in between each banner. Now, you may think, I'll never hang banners in a gym wall, which is fine, but believe me, I've hung enough pictures on walls and different things on walls in my house over the years to have to be able to know how to do that. So that's actually a pretty good problem as far as what you're gonna have to do at some point in your life probably. All right, last one, strategy 4, write a verbal model, then write an equation. Okay, it says a car used 16 gallons of gas and traveled a total distance of 460 miles. The car's fuel efficiency is 30 miles per gallon on the highway. So if you're on the interstate or whatever, getting 30 miles a gallon. If you're in the city, stop and go, just 25. How many gallons of gas were used on the highway? So it gets a certain amount, let's see, it is miles per gallon, so it gets a certain amount on the highway. So you would do 30 miles per gallon times how much it got on the highway, plus it gets 25 in the city times now. Instead of using something like y, here's what I know. I know it used 16 gallons altogether, and it used this much on the highway. So if it used that much on the highway, how much is left? And the answer is 16 minus that, whatever that number is. And altogether, we know that the distance is it went 460 miles. So let's see what happens here if I work that out. That's 460. 30 times x is 30x. I'm going to distribute right here. 25 times 16 is 400. 25 times negative x is negative 25x. So let's combine the x's on the right hand side. 30x minus 25x is 5x plus 400. I'm moving the 400 over there. That makes it 60 is 5x, so x is 12. Now think about what x was. X was how many gallons were used on the highway, and that's what it's asking. 12. That means there was 4 in the city and 12 on the highway. So 12 gallons, should put gallons there, were used on the highway. All right, those are just examples, and I think, pretty sure tomorrow when you come in, those are the only kind of 4 problems you're going to see. One of those strategies should work for you. Verbal model, draw a picture, you know, all the 4. I can't remember what the first one was, to be honest with you. So I'll see you in class tomorrow. Look forward to seeing you, and we'll work on this stuff like we always do. See you, bye.